Hi, I'm Carl Host from the Lincoln Electric Welding School in Cleveland, Ohio. And today we brought in a little different kind of job. I brought in a real-world job from battle wagons, radar mounts. It's a stainless steel radar mount for marine, for boats that are out in salt water. So it's made out of a 316L stainless steel, which is corrosion resistant in that kind of conditions, salt and fresh water. I've also got a 316L filler metal, and I'm going to be using a Pro Torch 20 water-cooled torch. Precision TIG 375. Also what I've done here is I've bolted this down to a heavy aluminum block. This aluminum is about 60% as efficient as copper for sucking heat away from the weld. And also the fact that it's a rigid block, it'll keep that stainless steel from distorting. That's one of the problems you have with stainless, is it grows a lot when it's heated up, and when it shrinks back up, it distorts and you end up with not a flat base. I want a nice flat base. So I bolted this down onto this heavy block as a heat sink and also to keep the stainless from distorting. I'm going to try and keep my heat input down by keeping a close arc length with my tungsten, using a large cup to keep the shielding on as long as possible so I don't get that blue color. I want to keep the stainless shiny. These will get buffed after I'm done welding them, but it makes the buffer's job a lot easier if I keep my shielding on until the piece cools down. Okay, we're looking at the front of the machine right now, and you'll notice there's a few extra bells and whistles on this machine. It's a 375. It's one of our top-of-the-line machines. One switch here is for my process that I'm using, and I'm going to be using gas tungsten arc welding, so I threw this switch in the down position. The next knob here is a kind of a nice feature for what I'm doing. I'm using kind of a larger tungsten. I'm getting older, so I like a 332 tungsten. Every once in a while I touch, and it tolerates that a little bit better. So when I'm using a 332 tungsten, they don't really like to start up till you get to 7 or 8 amps. So instead of the machine starting at the normal, when I hold this button over, you'll see 2 amps. I'm going to turn that knob up, hold that over and turn that up, and I'm going to start about 10 or 11 amps. That way I get a good hot start and the machine won't, the arc won't sputter on the starts. Here is my remote control switch. So I'm going to be controlling my current with my foot pedal. I've got my maximum current set around 96 amps. I'm only guessing. I'm going to probably be running about 80 amps when I make this weld, so I'll adjust the current with my foot pedal as I go. I'm not going to use any pulsing on this particular job. I'm just going to go with a steady current, probably around 80 amps. So I've got 4-step control. I have the pulser turned off. And my post flow, I'm going to keep that turned up to about 20 seconds. That's how long the gas stays on when I'm done welding. I'm going to keep the torch right there, and I'm going to turn my flow rate up. I'm going to be running about 35 on my flow rate back here. So a little higher than normal because of this large area that I'm covering. Tungsten's going to be extended a little farther than normal because I'm getting back behind an acute angle. So I would say I'm extended out about 3/4 of an inch beyond the Pyrex cup here. But with this big Pyrex cup and the high flow rate, I should be all right with that. Before we get started, we want to make sure we have all our correct safety equipment on. I have a Viking auto darkening welding hood on. I have the shade set for a shade 11 right now because I'm going to be TIG welding on some bright stainless steel, so I need a little bit darker lens than normal. I'm wearing ANSI approved safety glasses. These are the new red line safety glasses. They have a cheater in there. You know, I'm a little bit south of 45 years old, so more than a little bit, but I'm going to need these cheaters maybe to look at my weld when I'm done welding. I got the other cheater or diopter in my hood. I want to make sure I'm wearing a long sleeve shirt, and I have a flame retardant cotton shirt on today. I'm wearing thin TIG gloves. If you don't wear a long sleeve shirt, you can burn your arms. Your skin burns real fast with TIG. There's a lot of ultraviolet light with gas tungsten arc process. Also have ventilation here. I'm not going to make a lot of fumes. I'm TIG welding, very limited fumes, but it's a good idea to have ventilation because I am welding on stainless steel, and there's elements in that stainless steel that are really bad for you. Okay, we're going to get started here. I've got my tungsten sharpened up real good. I'm going to try and get in as close as I can to the work without touching. I'm going to use my exhaust system, so I'll turn this on. We'll get started. Stop every once in a while here. One of the things I do here when I get to the end of the weld is keep the torch right down there. Don't pull the torch away because that gas is still coming out and that piece is still hot. I don't want to discolor stainless steel. I'm at a point now where I have to extend my tungsten just a little bit further because I am in the acute part of this angle, and to get back to the back and keep my arc length close, I got to get out there just a little bit more than where I was. What's nice about that big, thick aluminum block is it pulls the heat out of that stainless real quick. Heat transfers into that aluminum quick. Stainless doesn't move very well. So my goal here was to keep the heat input down. And using the heat sink, that helped a lot. I kept my amperage as low as possible, but I also kept my travel speed up as high as possible. I kept my voltage down by keeping my arc length close. Kept the arc length close by extending my tungsten beyond this Pyrex cup as far as possible. That allowed me to get in real close and move along as quickly as I could. The less heat input, the less distortion, less problems we're going to have with buffing afterwards. This should polish up real nice. So you know there's a lot of different kinds of stainless. This is called an austenitic stainless. It's a non-magnetic stainless. It basically has about 18% chrome. Well, the base grades have 18% chrome, 8% nickel. But they vary the chrome and nickel content depending on service conditions of stainless steel. This happens to be a 316L stainless, which has a little more nickel in it, but it also has some moly added to the stainless. Anytime you're within 5 miles of the coast, they recommend 316L stainless because of pitting corrosion. Also, for a lot of industrial applications, chlorine in swimming pools, they often go to a 316 stainless. Food grade, sometimes 316 because some certain acids in foods will actually pit stainless steels too. So this is a little better grade of stainless than what your kitchen sink is made out of. I used a 1/16 316L filler wire on this, and I kept the size down. I try to keep my weld size as small as possible. I don't want too big of a weld because it's going to cause distortion, so I'm trying to keep the weld size down. If you'd like more information on TIG welding or TIG welding consumables, go to lincolnelectric.com.